Welcome everyone. Thanks for joining and thanks for being part of our community. A couple of reminders before we get started. This call is being recorded and we'll be posting the recording publicly on our tech community, so please be aware of that. If you have questions at any point, feel free to type them in the IM window, and then after we're further into the presentation, we will unmute everyone so people can ask questions verbally if they would like. Today we're lucky to have Sebastian Mollendijk with us, who is part of our customer exchange engineering team, and he's specifically on the Get to Production team who helps customers get deployed and set up with cloud app security. So he's in a great position to really explain and walk us through the 101 and make sure that everyone understands the fundamentals here. And then after the call, for those who qualify, we can help you get deployment assistance if that's something you're looking for. So without further ado, I'll turn it over to Sebastian so he can give us the introduction to cloud app security. Sebastian.
Thank you, Ryan, for the introduction. So hi, everybody, and thank you for joining this webcast where we'll talk about Microsoft Cloud App Security. So I will introduce the different capabilities of the product and also demonstrate some of the great features that we have there. So here is a short agenda for today. So we'll start by an introduction on CASB, Cloud Access Security Broker. So as everybody knows, or at least most of you probably knows this, cloud applications are now really critical for companies. Business users have now moved most of their workload to the cloud, and they are using a lot of applications. Most of those users are also using applications that are not managed by IT, or even for most of them, IT is not aware that any of those applications exist and are in use within your company, and of course, even less the kind of data and usage that people are putting in those specific applications. CASB is really there to help to solve those security issues and management issues. And here are some of our top CASB use cases. So one of the popular use cases that we have for cloud app security is first discovering the cloud application. As I said before, most of the applications are totally under the radar, and IT doesn't know that there is specific application in use within this company. So first they need to discover this application. But even if they have finally discovered which applications are in use in their company, they need to assess if the cloud application meet the company compliance and security requirements. So that's another use case for this specific type of solution to assess the risk for you instead of going to every application website and understand everything. When we've defined which application should be in use in your company, of course, we'll need to govern those applications, and when they are governed or defined as a sanction, we're able to take control of those applications by, for example, protecting and monitoring the access to your sensitive information, control also who is exfiltrated this kind of data or accessing from any kind of device or any location on the internet. And of course, really other popular use case is cloud threats detection, to be able to first detect to malicious action and then respond to those ones. Cloud App Security is, as I said, the Microsoft CASB solution and provides different capabilities to meet those use cases. So the first one we're going to discuss today will be discovery. So by using the traffic log that we'll send from your network appliance, we'll be able to first discover and then assess the applications that are in use in your company. And also using what we call App Connector, once you've governed and connected your cloud application, we'll be able, by using API connectors, to scan those applications to detect malicious access, but also the type of data that has been moved to those specific applications. And last but not least is the feature called Conditional Access App Control that was released recently in June, that will let us control in real time access to application from, for example, unmanaged devices, and to apply some extended control compared to Azure AD Conditional Access Control. Here you have a list of some of the applications with which we integrate. Like most of the popular ones are already integrated, and we integrate in several ways, like I will explain later. And you also see a subset of some of our customers for which you can find the testimonials on our website. So Discover Your Shadow IT. So Shadow IT, first to be sure that everybody knows what's Shadow IT. This is really what we explained at the beginning, applications that are in use without IT knowing about it. So the first thing that we'll do for this capability, so the feature name is called Discovering Cloud App Security. We'll be able, by using the traffic log that we will send to Cloud App Security, to identify applications that are in use within your company by matching those applications with our cloud catalog that has at the moment more than 16,000 applications. But you will be also able to add your own custom applications, so the ones that are used within your company, to be able to also detect access to those applications or anomalies when accessing to it. We'll be able to provide you more than 70 risk factors also for those applications. So we have a team of cloud analysts that will look at different capabilities, like security capabilities of those applications, but also regulatory certification, compliance standards, or other best practices that you would define within your company. We provide you what we call a risk score, and this risk score is calculated by some of the rules that we've defined by default, but that can be customized based on your own priorities. And once you have identified those applications, of course, the good way to continue the deployment would be to take control over those applications by onboarding them to Azure Active Directory, or maybe defining some blocking access for those applications using either Zscaler, or I will show you how to do that for other network appliances, or use the native integration that we have now with Windows Defender ATP. So here is a really high-level architecture document where you can see that for the different logs that we'll process, we will need to first collect, or to be more precise, send them to an appliance that we call a log collector. So a log collector will be a container running in your environment or in Azure that will send the logs in a secure way to Cloud App Security, where they will be parsed and to provide your visibility on the application in use in your company. And as I said, we have now a native integration with Windows Defender ATP to get visibility on applications that are used outside of your company boundaries. Based on that information, we'll be able to get information on the user, the IP, and the machine accessing those applications, in addition to the volume of those accesses. So we recently announced a native integration with Zscaler and other secure web gateways to be able to provide you first more visibility on Shadow IT and risk through the Zscaler console, but also a way to control the access to those discovered applications by defining that those applications should be unsanctioned or blocked in MCAS, and Zscaler will synchronize with those specific lists that we defined there to restrict access to those applications. And the seamless integration that we provide here is the fact that you do not need now to install a separate log collector in your environment to be able to collect that information into Cloud App Security. Let's move to a demo. So the first demo here will be on this specific discovery capability. So here you have the Cloud Discovery dashboard. So this is a dashboard that provides you visibility on the application categories that are in use in your company. So you can see in my environment that cloud storage is the one for which I have most of the traffic. And we provide you instant visibility on the traffic for applications that are seen as sanctioned, so managed by my company. Those are in green. Unsanctioned, those ones are in red. And the other, so the applications that are not yet being classified. We also provide you information about the risk level of those applications that are accessed, and the top list of those specific applications, plus the stop entities of those users. So if we go further now in the discovered application, you will have visibility, as I said, on all the applications that are in use within your company, and then you can start investigating in those applications. So we provide you by default some queries that could be searchable, but you can, of course, define yourself which filters you want to apply. For example, let's say that in your company, you're interested in finding the cloud storage applications that are in use within your company. You can easily move to cloud storage application and start working with the risk score that is available here. So for example, I could move to find all the applications that have a risk score of 4 or less. And you can go further by also adding some security risk factor list. For example, you could search, okay, I want to find application that supports SAML or do not support SAML. So why would this be important? Because, as I said before, when you've identified those applications, you want to centralize the management of those applications. So SAML will be most of the time a requirement from IT to be able to manage the end user access to those applications. So if I go a bit further now in those applications, for example, this specific application Weiyun, I see that it has a risk score of 4. I have here information about that application, like, for example, the location of the data. So as a European, usually I want to know if there is some data that are used by my user going to a data center outside of Europe. So this is first indicator here telling me, okay, you're connecting to China. So probably this is not compliant with your company requirement. You also see that in the security risk factors, there is no support for SAML for that specific application. And you see that there is no capability for defining password policy. And even worse, if we go to compliancy, you can see that it's not compliant with any of those specific certification. And regarding the legal capabilities for GDPR, for example, you can see that we do not have information from the vendor about this specific requirements or only a partial support for the user ownership. So having those specific criteria available for you, you'll be able to go further investigating the application that you want to manage in your company. When based on this specific information you want to go further, you can classify this application as being either sanctioned, meaning managed by my company, or unsanctioned. So I can easily choose that this application now will be defined as an unsanctioned, so that will be a manual process. And as I said before, when you do this specific operation, if you're using an integrated solution like Zscaler, you will be able to automatically block the access to that application to your user. Or what you could do, if you have another kind of appliance, is generate what we call a block script that will provide you the information about the domains and the IPs to be able to prevent access in your own environment. And all this process can be, of course, automated using our APIs and some scripts. Another thing that we provide also for discovery here is an executive report if you want to be able to provide your manager a report on the application that you've identified in your company. And this will generate a PDF file that can be sent then to your manager at regular time to be able to get more visibility on what's actually happening in your company. So this kind of investigation that I show you here can be extended also in addition to the discovered application by looking per application to the people that are using those specific SaaS application. So if I go to this specific Weiyun application that I've decided to block, I'm able to get an overview of the traffic, upload, download, but also the number of users, but also a trends across the usage of that specific application in my environment. So for example here, if you look at the download, you can see that it was heavily used in July, and starting September, most people stopped to use it. So that's also an indicator that you could use when you're looking at the adoption of SaaS application within your environment. You can also get, of course, a list of users using that specific application here, and also maybe alerts that have been triggered based on the usage of that specific application. And of course, you can go further per application in this specific way. So if I come back to my discovered application now, so you remember that I did perform some search based on some risk score here. Of course, this is not what you want to do every day. The thing that you could do is to automate the different criteria of the search by using what we call a policy. So if I click on that button, I can easily create a policy to automatically, for example, define application that will be tagged as unsanctioned. So if you remember, I've used a risk score, but you could add extra capabilities, like, for example, let's say that I want to have in the general risk factors, headquarters that do not equal, let's say, Canada, or choose whatever you want. And then you can also have a trigger of match when you have more than maybe 20 users using this application and the uploaded data is more than maybe 100 megs here. So when you've defined this, what you can do is then either send an email. That's probably not the way you're going to use this. Or what you can do based on the criteria that we've defined here in the filter is to either tag the application as unsanctioned to be able to block it, or maybe add a custom tag for example, say, okay, we need to have a review of this application. So by using a policy here, you're able to automatically classify your discovered application from within your company. So that's basically what you can easily see here. So another thing that we can do, because I told you that we have now integration with Windows Defender ATP, is to look at different reports that we can provide. So we have that global report that will be across all the sources within your company, but something that we have now is the Windows 10 endpoint reports. So those reports, as I said, are based on the integration with Windows Defender ATP. And in addition to the IP address and the usernames of people accessing those applications, we can now also have the information on the machine that are accessing specific application. So that's something that can be interesting for you if you're using, for example, shared computer across your company. Then you can go further and search for the application used by those specific applications. Those specific computers. So this is what we had here in Discovery. We can, of course, as I said before, customize some of those settings and go a bit further. So let's move to the slide. Other use case, protecting your data. So Cloud App Security natively integrates with Microsoft Information Protection Solution and lets you continue with the process that you've probably defined in your company using Discover, Classify, Protect, and Monitor. So how can we do that? So the first thing that you can do using Cloud App Security is first getting information about the files that are stored in your cloud application. So for IT, traditionally, data has been stored in file server or maybe on-premises SharePoint file, and that was good because you had some controls. Now that file have moved to the cloud, it's becoming more and more difficult for people to know the kind of data that's been uploaded in the cloud, who has access to this specific data, is my sensitive information shared with external parties, or I'm still compliant with the rules that have been defined in my companies. So all the specific question can now be answered by using Cloud App Security. So in Cloud App Security, what we'll be able to do is to govern the data in the cloud by using our DLP technologies. I will show you which one you're able to use here, but you will also be able to rely on Microsoft Azure Information Protection to be able to apply some classification. For example, let's say that you have some sensitive data that has been uploaded to the cloud and you're using some specific rules to identify that sensitive data. By using MCAS, you will be able to automatically apply the right classification based on the content or the location there. We also now an integration with the data classification service used by Office 365, and it provide now built-in sensitive information type for you to choose of, or you can of course define your own custom type for your company, like you would for Office 365 when you're defining those rules using specific regex or keywords in your environment. So let's have a look at this. So if I go now first to the investigation capabilities of Cloud App Security, you have access to files here. And the files, as I said, will provide you access to the files that are stored in our different cloud applications that are connected using our API connectors, like for example, Dropbox, G Suite, AWS, or of course Office 365. So a popular use case that we have when we deploy Cloud App Security is to be able to answer to question who has access to my data. Based on this filter here, you can easily find files that are shared publicly, so meaning with an anonymous link or with external people, by just querying Cloud App Security. And if you want to go further, you can, of course, find files based on their sensitivity using Azure Information Protection. And here maybe finding files that have been classified with confidential or highly confidential or even secret classification here. So when you find these specific documents that are shared externally and that should be based on this specific classification considered as really sensitive, you'll be able to investigate the actions related to those specific files. So for example, you can see here that I have a first file that has been classified. So if I look at this one, employee social security number, you see that based on this icon, it's protected with Azure Information Protection, and this is stored in Box. So it means that I'm able also to query files that are not stored in Microsoft application. And I can see here that I have different collaborators, and some of those collaborators are external. So you see that, for example, this specific user and this one also from Gmail has been granted access to this sensitive files. So you can see that the classification label here is highly confidential. So probably this is something that is not normal for that specific file to be shared externally. So when you're investigating those access to those files, you can always go to the related activities for your file and then be able to answer your manager's questions when they will ask you, okay, who shared that files with external people? Who accessed that files? Did we have a data leak there? So using this specific capability here, you're able to see who uploaded that file. For example, here, superadmin uploaded in Box from United Kingdom in June. You can see here that Cloud App Security applied an Azure Information Protection classification label automatically by using one of our policy to, because probably based on the content, which is social security number, we want to apply a specific classification here. And you can see also who accessed that file, who downloaded that file, or moved that file to another folder. And of course, you will see that also for external users. So that's an easy way to answer the question from your manager. So if you want to govern that data in a more efficient way than just investigating using the console, you can, as I said, create a policy. So if I create a file policy for governing my data here, I'll be able to first define the location where I want to search for my document. So you can here search for the different applications that are connected, like for example, Box, G Suite, and Office 365. You can search for the access level. Let's say that I want only for the public access here. And here in this case, I will not search for Azure Information Protection classification. Why? Because maybe in your company, you're just starting this kind of project and you know that most of the data is not yet classified with AIP capabilities. So what you can do is use the inspection method, either using the built-in DLP engine. So this is the DLP engine from Cloud App Security, the data classification service, which is common with Office 365, or even use a third-party DLP engine. So let's choose DCS, data classification service here, and let's choose for a specific sensitive information type. So you see that we have, as I said before, 90 predefined sensitive information, but you could, of course, use your custom ones. So let's move to GDPR file type, for example, as they're provided here. And let's say that I want to find all the EU passport number, EU social security number, and EU driver license number. So when you've done this, you have now the capability to scan those files based on the content and also maybe change the advanced setting by, for example, looking for minimum 5 occurrence of the EU password number in your files before considering this file as a match. When you've defined this, what you can do, of course, is apply some governance actions, so automated actions to protect your document, and go there to Box, for example, by either again, removing the external user, maybe moving this file to quarantine, preventing access from people that should not have access to this specific file, or using the native integration with AIP and selecting a specific classification label, like, for example, highly confidential data for all employees. And you can do the same or maybe different policy across your application, like, for example, for OneDrive, the only thing that you want to do is to send a policy digest to the user telling him that those specific files seems to be not compliant with the company policy. So that's really up to you, and ask them to correct what they're doing there. And I will cancel this to avoid breaking anything. Okay, so this is a short example of what you can do, and of course we can go much further based on those specific criteria. So back to the deck now. Another capability that we talk about is real-time monitoring and controls. So the solution that we use for doing this specific thing is using condition access app control, which is context-aware session capabilities that let us inspect every session of the user and take some decision, like, for example, monitoring the session, blocking the download of a specific type of documents, or maybe applying some restriction on the data, like a view-only mode for risky session, or maybe connecting from unmanaged devices. So you know that by applying that specific Azure information protection classification and encryption, the user that are not part of your company will not be able to access that specific data. Something to remember is that this is relying on the Azure Active Directory conditional access capability. So if you are today already using Azure AD conditional access app control extends those scenarios for the session of your user. But I will make a short demo to make it really obvious for you. So if we go to this slide here and this specific use case, let's think about a device that is not managed by your company, and the user connected on this device is trying to access one of your application. Application here can be Box, so it can be any SAML or OpenID Connect application managed by your company. And what you will do, you will define in Azure AD a conditional access policy that will define the risk of that session. So because here the device is not managed by my company, we'll consider that the session of this, the risk of this session is medium. And then when the user will try to access data on the application, we'll allow some specific accesses to the files. For example, let's say that this is a personal document. No problem, we let the user download that file. But if the user is trying to access sensitive information, so sensitive defined based on AIP classification or the content, then what we can do is to allow viewing in the application, and if the user is trying to download the file, we'll be applying an Azure Information Protection classification or just prevent the download of that specific file. So we have those different use cases that are available. So let's have a look at this capability. So before showing you the admin capabilities here, I'm going to show you the user experience. So let's say that I want to apply those classifications for Box. What I can do here when I'm accessing that specific application from an unmanaged device, so I'm not connecting on a domain joined computer or a device that is managed by Intune here. When I try to access that application, you can see that I'm prompted here and saying you're accessing to that application, and we are monitoring the actions that you will be performing. So this specific screen can be monitored. It's really up to you to define if you want to let your user know that you're monitoring them or not. It really depends on your company. But let's say that I want to continue to my cloud application now from my unmanaged device. And as an end user, you see that it seems pretty similar to my access when I'm on my company PC. But if you look at the URL here, because you're an admin and you're looking further, you can see that actually here at the end of the URL, we are redirecting the user to the Cloud App Security servers, where we'll be inspecting the user session. So what's the result of that inspection? So let's have a look at some content, for example, here, like social security number. As an end user, I'm able to access my data if I need to monitor it. And if I try to download that specific document on my PC, you can see that the download is blocked. Why is it blocked? Because this document is marked as confidential, and again, confidential can be AIP or content-based, and I know that I'm not able to go further. So that was the first use case here, but if I look, for example, at that specific document, the ON agenda, that information is probably less sensitive for my company. So let's try to download this specific document on my unmanaged PC. And for this specific case, you can see that the download just worked. So if I open that document now, you'll be able to quickly see that I'm configuring Azure Information Protection here. And the reason is that when I downloaded this file, you probably don't see anything actually because it's AIP protected. But just to show here that I'm still there, you do not see it, but I've been here applying a view-only template from Azure Information Protection, preventing any other access than just viewing that specific content. So this is really up to you to configure which specific classification you want to apply, but at least that's an extra use case for letting user access information by securing it at download from unmanaged devices or risky sessions. What you just saw here is working for my company user, but another use case could be also B2B users. So that's a restriction that you could apply to maybe contractors or partners working with you and when you're sharing some internal documents with them. So you could prevent, for example, downloads across your different cloud storage application there. So that was the end user experience, but let's move to the admin one. By first investigating in the activities that were performed by my end user. So when I go to the activity log, so the activity log is a way in Cloud App Security for search about all the different activities that have been performed across all my cloud application. You can see here, if I come back to this specific location, that my user called Sylvia has been redirected to session control. So when my user authenticated, I know that I've been redirected through Cloud App Security. You can see that I previewed the file, and you can see also that the downloaded file here, this is the social security number file that I tried to download here, was first passed to Cloud App Security for analysis. And here you can see that when I, as an end user, tried to download the file, the download was blocked here. I have my browser freezing a bit. So that's the first use case when I tried to download and we blocked the download of that document. For the next file, the ON agenda, you can see here, because you didn't see during the presentation, that this file, my user Sylvia was able to download it, but we apply on the fly an Azure Information Protection template just to be sure that this specific document or this specific kind of document is now protected when my user tried to access it. Okay, so those are some of the cases when you're investigating for those actions. How can you define this? So there are two ways to do this. So as I said before, you need to first use the conditional access policies to do so. So you define one of your policy. So you define the people to which you want to apply those restrictions. So usually we start with a small group of users. You define the cloud application to which you apply to this restriction. You define your different condition for applying this specific conditional access. And when it's done, what you can do is to use the session control capability of Azure AD. And then you say, I want to use conditional access app control. And when it's done, you can now go back from this policy to Cloud App Security, where you will define extra rules there. And those rules can be based on the user, can be based on the different. Yep, let's move here to the policies. So it can be based on the device type, can be based also on the location. So really define what you want to do. And let's go to the session policies here. Just to show you the different capabilities that we have. And when you define session control using this capability, you can either first start by monitoring your user. So most people start with it just to avoid blocking their user. Or you can define that you want to control the file download. That's what I showed you. So you can define that based on specific criteria here, based on the content of the document, you can either block the download or protect it using Azure Information Protection capabilities. So that's what I showed you to during the demonstration. Or another thing that you can do for the onboarded application is define which activities you want to block. For example, for the onboarded application, what you could do is to, for example, prevent to create a Jira issue when you're not in a specific location, like within your company. Or maybe you want to just prevent the sharing of the item, or the unsharing of the item, or the uploading of the item. For example, for Box, a use case that we have is to configure the access to Box as read-only mode for B2B user. People will be able to see the files that are stored there using their browser, but they will not be able to modify your files. They will not be able to upload any files or download any files. So those are some of the capabilities that you could have here. So let's move back now to the deck and protect from cyber threats, which is also a really good example of what a CASB can do for you. So in the protection against cloud threats, we have several scenarios that are supported by default. Excuse me. Like, for example, the malicious insider, where you can detect when an employee is trying to cause some damage to a company by, for example, exfiltrating some data or accessing in an unusual way to your company application. We can also detect malware in any cloud storage application that you're connected to as soon as it's been uploaded and just alert you. We can also identify when a ransomware has been accessing your data. Let's imagine when you have a user's PC that has been compromised, and that PC is synchronizing all the user files to OneDrive. We can easily detect those specific actions based on the behavior analytics technology that we have. We can also detect now rogue application accessing your data. I will show you how these things work. Also detect compromised account when you have people accessing from a different location, for example, your Azure Active Directory or your different applications. So in the different detection that we have here are some of the examples that I already talked about. But one of the newest one that we have is the suspicious inbox rules detection. So for example, that covers the scenario when you have an attacker that has been able to compromise an account and access to the mailbox, and that specific person will create a malicious inbox rules to forward specific emails to an external mailbox. Most of the time, users do not realize that data is being sent outside the company just because they're able to mimic the rules that exist already in the mailbox, and user will not have any clue that data is being exfiltrated in this way. In the different other activities that we're able to monitor is, of course, access from suspicious IPs or anonymous IPs. But also, based on the machine learning capabilities and the user behavior analytics that we have, we're able to detect when a user is accessing your application from an infringement country or performing action like impossible travel. So those are the things that we're able to do here in those specific cases. And other ones that you have also by default, again, based on the machine learning, is unusual access to your company data, unusual download, or deletion of those specific files. Activity by a terminated employee is also a popular detection, because if you think about those applications that are not managed by IT but delegated, so the administration has been delegated to some of the users that are managing that specific application, most of the time they will not have a correct management of the user account that are in use in those specific application. And let's say that you have a user that has left the company, the AD account has been terminated. but in that specific application, there is still a reference, there is still an account for that user. We'll be able to detect if that account is still being used in that specific application. And of course, malicious use of privileged account are able to be detected here. So let's have a short demo. So if I look to the policies at first, I'm able to see the different anomaly detection policies that we have. And in those specific policies, so those are some default policies that are enabled in your environment to be able to provide you more protection. You can see that all those ones are for threat detection. For example, let's think about unusual file share activity by user. That's a policy that exists by default, and that will be able to detect based on the user usual activities if there is a sharing activity that seems suspicious to us. So you see that there is nothing to configure just because we are using the learning period that we had and the profile of that user that we created to detect and alert you when something seems wrong. You can see that we have a lot of those activities by default, but you can of course create your own policies to detect specific actions. For example, you could create your own activity policies and define which actions you want to monitor for threat detection. So when you want to create those policies, you can, as I did before, create them from scratch. Or what you can do is use the templates that we provide. For example, you see that we have several of them, like outdated browser, mass download for your user, or maybe log on from a risky IP. And when you choose that template, automatically you see that the filters are applied by your user. So after that, you're able to customize this by modifying the alerts that you want to have here, sending an email, maybe adding extra filters in this action. And you're able then to also add maybe governance action, like for Office 365, require the user to sign in again or suspend him. So those are some of the actions that you could do here, depending on the application capabilities. Another thing that you also have here is the malware detection in your cloud storage application. And again, this policy will be enabled by default for you. So, it exists by default in your environment, and it will just provide you visibility on the malware that has been detected in your cloud environment. So if I go and check the different matches of the infected files in my environment, using that specific capability, I'll be able to see which files exist in my environment and that are considered as suspicious. Again, it's in Office 365, but also in other connected applications like Vox in this case. So if I click here on the specific file that has been seen as infected here, you can see the status. You see the malware type. So here in our case, it's just an ECAR test files. So you're able to go further by looking at this here and get the security report from the Microsoft Threat Intelligence. So if you need to investigate about this malware, it's available there in our console, and you're able to go further and see also which activities again were related to this file. So if I look for this specific infected files about the related activities, I'll be able to see who uploaded that file and who accessed that specific file here. So that's also a way to go further by using the Cloud App Security to investigate in your environment to be sure of detecting what happened. So you see, for example, that this file was uploaded here again in June by that user, and we also enabled a sharing for this file, meaning that maybe some specific user in my company or external to my company downloaded that file that was a malware. So you were able to go back to them and investigate if they've been compromised or not. So let's go back to the deck just to show you other capabilities. I just show you the malware detection here. again, as I said, it's powered by the Microsoft Threat Intelligence. And one of the great capabilities that we have now, and that I will demo you just after, is the OAuth app permission detection. So the OAuth app permission detection capabilities here help us to monitor the cloud permission that are granted by your user by an application. So if we think about, let's think about, for example, your Facebook account. When you're using your Facebook account to access some application, you've probably seen a prompt asking you to grant some consent. So we have exactly the same thing for Office 365 or G Suite, Salesforce, when your user are prompted to grant some application access to their applications. So like access my file, for example, for Office 365. Those applications can be suspicious, and they can be granted actually much more permission that you would allow normally in your environment. So something new that we announced is also the automated permission policies. So we'll be able to automatically revoke risky application in addition to also just alerting you. So let's have a quick look at this specific feature. So you can find in the investigation, ARP permission, and there you will see the different application here in your environment. For example, you can see some Microsoft trusted application here, like the Graph Explorer, and you can see also number of users impacted by that specific application and the permission level. So let's say that I'm interested by permission level with high severity. You can see here exactly who has granted what to those applications. And for example, if I look to the Nintex SharePoint, another things that we provide you is the information about the community use. And you can see here that this is rare, meaning that across our different customer, we do not see frequently that specific application. So maybe for you in your company, that's something that you want to know when a specific application which is granted high-level permission, like have full access to the user profile and access to all the item in SharePoint, and that specific application is pretty rare, maybe you want to revoke the access. So based on the information you have here, you'll be able to ban the application, but this will be global for your users. So be careful. We recommend to first contact the user. So we provide you the information about the user that have granted access to that specific application. So try to define the right process before blocking those applications. So another thing that we have now in the cloud app security environment is also the, as I said, investigation on anonymous admin behavior, but we also have capabilities for the AWS or Azure platform. So we have now a unique integration with Azure Security Center to provide you visibility on the different action you should take when you want to protect your Azure environment. And you can also search for AWS activities, like, for example, people granting access to S3 buckets, or maybe people deleting the VM in your environment. So you can be alerted on those specific things there. Just to show you the native integration that we have with here Azure. So if I go to security configuration here, I'm able to see from Cloud App Security the recommendations that are provided by Azure Security Center. So here you can see, for example, that in my environment I have some recommendation, and I can pivot now to Azure Security Center to get that information. So instead of going to both places, you can easily see here those specific action. And if you have different subscription, I only have one in my environment, you could go further across and investigate across all those different subscription or the recommendation types. So those are some of the different things that you can do with Cloud App Security. I think we've covered a lot today, but you can go, of course, even further. In the next step that we propose is to first start your Cloud App Security trial. You can easily click it and access a trial for just testing it. Probably that most of you already owns those licenses, so you can easily start using Cloud App Security. You can easily integrate it with Office 365. So if you're global admin, it will take you maximum 2 minutes to be able to start getting the value of Cloud App Security for environment. And you can, of course, connect more cloud application, third-party application that you will have. You can also contact us. So we recommend you that you join our community to be able to get visibility on what's coming in Cloud App Security, propose also some improvement, or ask any question you want there. We'll also post this specific recording on YouTube, so we'll be send an email with the information how to join those communities and also watch the video. So I want to thank you for the presentation here, and I think we'll open now the mics for answering some extra questions that you would have. Thank you.
Thank you, Sebastian. I've unmuted all of the participants, so if anyone would like to ask a question verbally, feel free. Or if you're more comfortable typing the question in the IM window, we'll take questions either way. Looks like we've got a question from Charles. How is the tool able to see so much detail? Do we need to SSL intercept?
It depends of the type of integration you're talking about. So if we talk about the Office 365 or box capabilities that I showed you, we're using APIs to access those applications, and we have to delegate access. So we have we can, if you want, somebody can post the link here. We need some specific permission depending of the application, and then we're able to access that specific kind of information. Regarding the Shadow IT part, we rely on the logs that you send to Cloud App Security. So it depends of the appliance. So some appliances are able to send more information than the other ones, and then we're able to really go deeper in that specific information. Something also to know, I didn't show it here, but you're able to anonymize the information that is sent to Cloud App Security if you have some privacy concern. So we're able to also do this kind of thing for that specific kind of traffic. So another question from Enzo, group that can help us with best practice configuration. Yes, we have. So depending of the size of your company, we can you can engage with our team, or you can also use Microsoft consultancy services that has a specific offer for Cloud App Security. Another question, please, would you help me understand concept of subscription when we say security configuration in subscription? What exactly does it mean? So, so that question, subscription is the Azure subscription. So it's based on the subscription permission you have, or you will be able to get that specific information. I hope it answers your question. If not, you can post it again. We have the person in charge of that specific feature in the call. Next one, is it possible to get the Azure Information Protection Data Classification Service to scan the files stored in SharePoint and send a digest to the site owner, not to the file owner? To the site owner, I don't think so. Maybe Dima, you can correct me, but I don't think that you have this capability. Maybe a workaround would be to query the API or use the PowerShell module to be able to get that information and generate a report. I don't think that we can do it through the console, but using the API, you could probably generate this kind of report.
Yeah, so you cannot automatically determine the site owner, but you can manually provide the email of who you want to receive that alert. So, okay, if you generate the report from SharePoint, you can just set up in the policy to send it to the owner that you determined earlier.
Okay, so this is not here automated, yeah. So For Enzo, how do I contact my TAM? You can contact your TAM, yes. He's probably aware of their offer. Are there any improvement to the ransomware detection policy? Okay, Enzo, for the, I don't know, regarding your specific cases, are you talking about the specific policy that we have a template for the ransomware detection? Okay, so for this one we have a new policy that it's using more advanced capabilities. So maybe Gal, you can, if you want to give more details about this one, or I can show the policy. But we have now, so we're not going to look now for the ransomware to specific extension like we used before. We're going to use now the machine learning and look at the different activities that a ransomware will perform most of the time.
Exactly. The point here is to identify the behavior of the ransomware rather than just specific extensions or specific files. And you can have them both enabled at the same time. And the template is the one that is more deterministic. It looks specifically for files with specific extensions, while the machine learning one looks for the behavior of the ransomware. And the two scenarios combine pretty good together.
Thanks, you got it. In Security and Compliance Center, for me to set up a threat policy, what role is required? I've seen the documentation. I need global admin. Why need to be a global admin to define new security policies in threat protection? Is it not too much wide access? Thank you. So here, this is you're really looking at, if I'm not wrong, to the Office 365 Security and Compliance Center. So this is a separate product there. But I think you need global admin permissions basically for accessing completely the specific that specific kind of information. So for this one, I don't know if they're planning to provide you some other way to avoid this, like creating a dedicated rules. I'm sorry, I don't have this information here. You're welcome. Thank you.
We'll give another minute here for any additional questions.
Yeah, and if you need or more information later, or if you have other question that just pop up, you can go to the link that Ryan posted, aka.ms/security community, where you can answer your questions. Mass download by a single user continues to be a problem for us. The policy continues to detect when the new machine are deployed and the OneDrive are cached back onto the machine. Any improvement in that policy? For this one, I don't know. I don't know, Gal, if we'll be able to improve this. I assume that if we want to go further with this specific detection, we need to be able to identify those computers, meaning that you need to have hybrid AD configured to be able to know the machine identities there.
So again, it's a similar scenario to the ransomware one. Mass download by a single user is an activity policy, which is a deterministic one. So it applies to specific scenarios of single users, while the machine learning detection identifies, takes into account the baseline behavior of the user that we profile over time. So for the larger scenario, the machine learning detection should cover all of the malicious activities, while mass download by a single user should only be used for specific users that we're more concerned with.
Additionally, this is Gershwin. Additionally, we're working with the OneDrive SharePoint team to be able to get a differentiation between when something is being done via sync and once something is actually being downloaded by the web client. So that's something that we're also working on, so that will make that eliminate that from that detection.
So another question, impossible travel seems to be a big area for false positive. Any way to reduce that? The first thing to do would be to first define your company IP addresses. Yeah, Gal, you have something else?
Yes, so specifically about impossible travel. So yeah, sure, we're constantly adding more and more logic to impossible travel to eliminate scenarios that we identify as false positives. I must say that oftentimes impossible travel is a tough scenario to identify. I mean, for every organization, this identification may be a bit different. For example, some organizations may define roaming scenarios where the user is actually using devices in two places as false positives, while others don't, and we prefer today to alert on both scenarios. In the future, we would like to be able to have sensitivity mechanism to the algorithm, so each and every customer can define the detection specifically to their needs. And this is something that we're working on at this point.
There's another question from Enzo. I have a specific policy related to attacks from countries we have problem with. It is necessary still, or does your UBA now take care of this? And I can remove that policy. I would say it depends, because, of course, they can use IPs that will be in. If you use that specific deterministic policy, they can always use PCs that will be in the allowed or non-detectable countries. Here, at least, using the UBA, you can have some alerts that will pop up when we discover another anomaly for that user accessing from infrequent countries, for example. So that could probably help you for this case.
Yes, I will also add that it's part of every organization's decision. So, for example, one organization would like to be alerted on every login from Nigeria, and so in this case, if I have regular activity from Nigeria, let's say that I have a branch in Nigeria, then the machine learning one will not detect this kind of activity as abnormal. So if I want to be alerted on each and every activity, I will have to set up the deterministic detection. In this case, the machine learning detection focuses really to identify the suspicious things, the abnormal things that don't happen often. So if you want to focus on specific countries and have deterministic detection for those, then you would use the activity policy one.
Another question here, also one important point of notifying everyone. Say I have a prepaid dummy marketing redemption card that has a 16-digit number, random number. This is sent outside. This triggers a credit card DLP alert. Why is the tool not validating credit card debit number to load formula before raising the alert? Has not all 16-digit number or credit debit card number seems to be currently missing in the logic. I think if you use the data classification service, that will probably solve that specific issue, because Office 365 should really help there to improve that specific kind of detection. Can you maybe tell me if you've been using some specific rules, maybe from the initial native engine? Okay, and are you using the data classification service? Okay. Okay, so I'm surprised for this one, because that's the Office 365 one. That's something we can investigate. Maybe if you can contact us and send your dummy ones, but that shouldn't trigger an alerts. I don't know if reach out to the team and say, okay. So Dima, I don't know if you have feedback for this specific question.
Yeah, this is the detection performed by the Office team, and if you can send us the info, I'll reach out to them and ask them what's the logic behind it.
No, not on everything, because exposing all our logic will allow the malicious people trying to avoid the user will be able then to avoid it. Yeah. You're welcome. That's nice. We have a lot of questions. We still have time for more questions if you want, or again, don't forget to join the community if you have more. I don't know if there is some question here. Oh, I see that some people leave it. Yeah, one more. Go ahead. Yeah. Okay, it is very difficult to determine the cause of multiple fail-logon alerts. We have MFA enabled and we never know why it's happening. Yeah, that's okay. Yeah, that's true that it can be difficult to see it. What you can do in Cloud App Security, but also in Azure AD, is to go to the raw data from the login attempt, and most of the time you have much more information there regarding the authentication attempt, like the user agent is provided, but sometimes you will find more information in those specific log about the endpoint that was called, or maybe the user agent. Yeah, I know that's not an easy one, but we're probably looking at improving those ones too. That's always difficult because you can have applications that are maybe configured to use some credential and trying to do it. So yeah, that's the investigation you should do.
Just to add to that, Sebastian, that we're looking to expose the MFA results in a more visible place in the product. We'll be able to filter based on that and also decide whether you want to include these kind of events in the different detections. So basically, we'll be able to say, for example, if there's an MFA challenge, a failed MFA challenge will not be considered as a failed login. Just an idea of what we're doing to improve it. No specific ETA at the moment, but it's something that we're already working on at this time.
So I assume the question about the people working in the area are more related for people outside Microsoft. So if you're talking specifically about the permissions for Cloud App Security, you need global admin or security admin to be able to deploy it. And depending on the application requirements, you will need to have some specific requirements based on the application requirements to configure them. And as Gershon just posted in the link here, once you have enabled the service, you're able to delegate admin access without granting global admin permission to user. So you can grant some people within your company or outside your company access to the management console, or what you can also do is scope the administration to specific groups. For example, you could say that you want to let a specific group of users monitoring the activities and alerts of a specific department, maybe based on geo requirements. That's something that you could do by delegating admin access to Cloud App Security. Thanks to you for attending. And if you have any question, don't hesitate to join the community, as Ryan said.
All right, last call for any additional questions. And again, if anyone is looking for the recording, there's the link that I'll be posting it to there shortly on the MCAS group. All right, with that, thank you, Sebastian, for a very informative presentation, and thank you to all of you who joined us, and we appreciate your engagement and your questions and feedback. They really help us. Thanks for joining us, and thanks for being part of our community.
Thank you all. Bye. Have a great day.